Hello and welcome, folks. We are just getting ready to get started on today's webinar. We're going to let people drift in for the next 30, 45 seconds or so, but appreciate everyone joining so far. Alrighty. Well, thank you everyone for joining. We're super excited for this topic. It's something that is near and dear to our hearts. We're going to be talking through how and when to fine tune and serve LLMs in your cloud. We've been getting a lot of questions about this topic lately, and we're super excited to share our point of view, walk you through part of our platform, and hopefully give each of you something good to, some knowledge to walk away from to help accelerate your own path to AI. So a few housekeeping items before we get started. All lines are currently muted, but we do have a chat on the right side of your screen. You should see it there. It's a public chat, so feel free to add comments, questions, engage with each other there. We love the public chat because we honestly see a lot of really good dialogue in there. So please keep it coming. You'll also see that there are some polls to the right there. So we have a few questions just to learn more about our audience, learn what is top of mind for you all, so we can, help provide the best content for you on your journeys. So please take a minute to answer each of those questions. I think we have 6 questions in there today. We really appreciate it. Helps make our future sessions more valuable for you. We are, of course, recording this. It'll be automatically sent out to everyone who registered. So you'll see that, in the coming days, linked to the recording on YouTube. And like always, feel free, if you like what you're seeing here, especially when we get to the demo later on, feel free to go to this link here. It'll be linked on that right panel later on. But check out Predabase for a 2-week free trial. We have access to the whole platform there, so you can kick the tires as you see fit. And if you are fine-tuning LLMs and building AI, feel free to also join our open source community at Ludwig. So with that, I'm going to introduce our speakers today. So we have Abe Malik. He's a product manager here at Predabase, has a lot of background and knowledge to share with us today. And we have Connor McCormick, who's one of our data scientists and solution architects. So he'll be walking us through the live demo later on, where you'll be able to see the platform in action. And with that, I am going to stop sharing my screen and hand things over to Abe. So thanks, everyone.
Awesome. Let me go ahead and share my screen. Cool. Sweet. Thanks everyone for coming out today. We're very excited to talk to you about how and when to fine-tune LLMs in your own cloud. As a quick agenda discussion, today what we're going to do is give you a brief overview of the LLM and deep learning revolution. We'll also talk about some different ways you can customize LLMs to your tasks, including 2 of the most popular in fine-tuning and RAG. Since Predabase specifically is focused on helping you fine-tune and serve LLMs, we'll also dive into fine-tuning specifically, talk about some of the challenges with fine-tuning and serving LLMs, and then wrap up with a live demo of how easy Predabase makes it to get started on the journey of fine-tuning and serving in your organization. So today, the LLM revolution is here, and it's driven by cutting-edge deep learning models. Deep learning itself is important because it allows organizations to take advantage of both unstructured and structured data. From the pre-deep learning era of models like XGBoost and CapBoost to the current era of models like BERT and GPT, we've seen that an ongoing trend that has emerged to train larger and larger models. Recently, we've seen the models continue to increase from models like BERT, around 300 million parameters, to much larger models like Llama 2 at 70 billion, or even GPT-4, which is over 1 trillion parameters. The largest variants of these models, such as GPT-4, have also displayed emergent properties that are not present in some of the earlier, smaller models. So now LLMs are able to perform tasks like arithmetic, question answering, summarization, that they weren't explicitly even trained on. And so with all of this, and with AI being able to tackle more and more tasks, the question that inevitably arises is, how should enterprises think about making the best use of these LLMs? The answer, as expected, should always be to start with the problem and the use case, and not the technology. And so that's why for most organizations, bigger and more generalized models isn't always better. One of my favorite customer quotes that really drove this home for me was when a customer said, "Hey, I don't need my point of sale system to recite French poetry." And so as we'll see in the next slide, there are actually a few different options enterprises have when they think about customizing their own LLM. So in this graph from our co-founder Piero, we can see a few different methods of customizing LLM, plotted based on the amount of labeled data you have available and the task type. And so on one end, on the right side, we can see that prompting a general model is the easiest and recommended way to get started to quickly build a prototype, because you don't really need any labeled data at all. So there, as you can imagine, there are a lot of benefits with this approach. The pre-trained general models have already been trained on trillions of tokens of internet data, and if it works, you can see immediate results without any additional effort. However, there are also a few major downsides, including the fact that they're often expensive and bloated, especially if you want to host your own large language model. It's often overkill for especially in the cases where what you're really trying to do is train task-specific models, or have your LLM solve very specific tasks. On the other end of the extreme, you can see training from scratch. And so you have this option to go ahead and build your own LLM all the way from scratch. While this is certainly appealing for a variety of reasons, there are a few blockers we often see customers bring up. One is the lack of available training data. So usually the amount of training data you need to train your own LLM from scratch is anywhere in the amount of billions to trillions of tokens of data. And the second is the exorbitant cost, because usually it costs around upwards of $1 million to train a single LLM. And so at Predabase, we believe organizations should start small and take an iterative approach to see what models work for their use cases. And so specifically, two high ROI use cases we see a lot of customers come to us with are RAG, Retrieval-Augmented-Generation, and fine-tuning. And so with that in mind, one of the questions you may have is, okay, well, between RAG and fine-tuning, which one is right for me? The short answer is it depends a lot on your use case. And for a longer answer, let's dive into a little bit about how each of these work so you can understand the nuances of each and when it makes sense to apply them. So let's start with RAG. At a high level, Retrieval-Augmented-Generation is a system that combines a few things. The first is a retriever system. So what this does is it fetches relevant snippets from your domain-specific corpus or dataset. This is often implemented using an embedding model and a corresponding vector store. So you may have heard of systems like Milvus or Weaviate that can help store the embeddings of your specific document chunks. The other part that's really important is your base LLM. So this is what takes the relevant chunks that are fetched from your embedding model and uses that to generate a response to the user. And so a key motivation of RAG systems overall is that LLMs themselves have limited context windows. And so it's extremely important that you feed the LLM with the right context at inference time. And so in some ways, you can consider RAG actually as an extension of what's called in-context learning, where you're feeding the LLM with the relevant context for a given query. In contrast, fine-tuning is a process of further training a pre-trained model on a specific task or domain using a small labeled dataset. And so this process customizes the model to the task, by leveraging both the pre-trained knowledge of the original base model as well as the nuances and intricacies of your own domain-specific dataset. And so this is different from RAG because in this case, we're actually training the model and changing the internal model weights and parameters based on our label dataset. And so from our experiments, fine-tuning typically allows the model to perform better and achieve higher accuracy on specific tasks compared to more pre-trained general models, which haven't been tuned for these purposes. So now that we've gone over RAG and fine-tuning, how should you think about when to apply each? Here we've listed out some of the key considerations you should keep in mind when deciding between them. Before we dive in, it is important to remember that RAG and fine-tuning are doing fundamentally different things, right? So the first criteria here is, do you need an external system, whether that's like a document store or something else? And this is where RAG really excels, because as we talked about, RAG is really this idea of allowing you to fetch in relevant content from different various external systems, right? As compared to fine-tuning, which is really relies on that labeled data set that you provide at training time, right? And so if you do need an external system, RAG is probably something that you should heavily consider. The next question here is, do you need to modify the model behavior itself or inject domain-specific knowledge? And so as we talked about, RAG is really about feeding that domain knowledge at inference time into the prompt when you're going ahead and prompting that model. And so there are no model changes that are involved in a RAG system. Compare that to fine-tuning, where you're actually changing the model itself and the internal model weights depending on or based on the data that you're feeding it during the fine-tuning process. The next question here is the task standardized or is it repeatable? So for example, RAG works really well for Q&A type use cases, where you have a set of documents and you want to go ahead and users want to ask queries, and then you can go ahead, search through your documents in sort of like a typical information retrieval type task, and go ahead and fetch the most relevant documents or snippets of those documents to return to the user. Fine-tuning, on the other hand, works well where you have repeatable standardized tasks, such as like generating structured output or modifying the tone in a specific way. And then the final question here is ultimately, do you have training data available, right? Because RAG, as we just discussed, doesn't really use any labeled training data. All it does is kind of do a search over your corpus of data, whereas fine-tuning is very useful for when you have historical examples of what the model should be trained or tuned to do, right? And so ultimately then uses those input-output pairs to better understand the nuances and intricacies of the task that you're trying to do. While these are some of the key factors, there are likely also other secondary factors you should also keep in mind. So things that are more relevant for productionizing these systems. So you can imagine factors such as like latency requirements, scalability, long-term support, which are also very important to keep in mind as you think about making these production ready. The last thing I'll mention here is that RAG and fine-tuning, although they're often framed as one versus the other, they're actually not mutually exclusive. Specifically, if you're building like a Q&A type system, there's definitely a possibility for using both RAG and fine-tuning. And so one way you can do that is you can consider that within RAG, there's an embedding model, right? That's used to embed and fetch the closest documents or snippets. And so what you can do is as you build your RAG system, you can actually fine-tune that embedding model on input-output pairs of, let's say, a query and a associated relevant document, right? To improve the performance of that embedding model. Experiments have shown that fine-tuning an embedding model can actually lead from anywhere from a 5 to 10% increase in retrieval evaluation metrics. So it's definitely something to consider if you are building a Q&A type system. However, since Predabase excels as the platform for fine-tuning and serving LLMs, let's now turn our attention to fine-tuning specifically. So as we've discussed, fine-tuning helps LLMs improve performance on domain-specific tasks as compared to larger general models. And so as you think about when to apply fine-tuning, here are some scenarios that may be helpful as a sort of heuristic or frame of reference. When fine-tuning, do keep in mind that the fine-tuning process itself does require a data set, and that this data set is typically in the form of input-output pairs, and you should have at least a few hundred examples, labeled examples, although more certainly doesn't hurt. So let's start with instruction fine-tuning. This is the process of taking an LLM and fine-tuning it using an instruction data set. And so what that means is you're teaching the LLM to follow instructions, which is useful for for improving out-of-the-box performance. And so as an example, you may have noticed that, especially with a lot of these open source models that are released, many models come out with two or multiple variants, usually a base model and an instruction fine-tuned model, often called chat, right? So there's like Llama 2.7 billion and there's Llama 2.7 billion chat. And what they're doing here is they're instruction tuning the base model so that it's optimized for dialogue use cases, so that when users are interacting with it, they have a better experience because the LLM has been trained to better respond to human queries. There are a few different ways you can come up with a data set specifically for instruction fine-tuning. You can imagine that your data set already has instructions, in which case, great, you can go ahead and get started. But even if it doesn't, you can also convert an existing data set by simply prepending the instructions to the input column. The next example we'll cover is domain adaptation. So this is taking an LLM, which has been trained to generate text, and tuning it on a specific field, so it understands domain-specific knowledge, vocabulary, tone, etc. So examples of this would be generating structured output for a specific task, or even generating like language-specific code, like SQL, for example. As one example, let's say in a domain, you can imagine you're an insurance company that has claim responses, and you're trying to generate those now with an LLM using generative AI. While an LLM can generate the text out of the box, if you want to use these results in a production setting, you likely want these responses to be tuned to how you historically have been answering these claims, right? And so these responses have to be written in a certain style and a certain tone, right? And so this is where you probably have a labeled data set in the past, and you can easily use that to fine-tune an open source LLM for your specific case and make it very, very effective and accurate. The last is task adaptation. So this is when you're using an existing LLM, but you're modifying it to a specific task, and it's often a predictive one. And so while LLMs themselves are typically trained to generate text via next word prediction, you can now fine-tune it to tailor to other types of tasks. And so in theory, you can imagine you can actually just use an LLM out of the box via in-context learning to do this. So you can say, hey, can you help classify the sentiment of a given piece of text? You can also improve this via fine-tuning, where if you have specific examples of the specific task you're trying to do, whether that's sentiment classification or turn prediction, you can kind of feed that in and further train the model via task adaptation. Sweet. So now when you think about productionizing this, and let's say you have a fine-tuning use case, you have your data set, you've gone ahead and are interested in fine-tuning, how should you think about productionizing LLMs? There are a few major blockers we see companies face on this journey. The first is complex tooling. So customers and users are very interested in fine-tuning, and they honestly just kind of want to experiment and see if it works for them, right? The reality of today's ecosystem is that it's just very fragmented, right? And there's a continuously changing set of best practices. And so there are many tools, both open source and commercial, and it's easy to get analysis paralysis, especially if you're looking for one unified end-to-end solution. Another challenge is the practice of fine-tuning itself. Given that these models are so large, doing model parallel distributed training is often complex and intricate. Often we see users run into issues like out of memory issues that are really tricky to debug. And finally, after you have your fine-tuned model, it's not really useful unless you have cutting-edge infra and have it efficiently scale up and down to meet SLAs. And so that's where Predibase comes in. The Predibase platform takes a declarative approach that allows you to fine-tune and deploy any open source model, from smaller models like BERT to even larger models like Llama 270 billion. We build in best practices like parameter-efficient fine-tuning, right-sized serverless training infrastructure, so your workloads just work. If you desire control, we also allow you to specify and leverage the compute resources and training parameters used for specific jobs. And so you can specify, for example, which GPUs you want to use, from anything from a single T4 to an entire cluster of A100s. And lastly, you can do all of this, including serving these fine-tuned models on our managed infrastructure or your own cloud, whether that's AWS, GCP, or Azure. And so to summarize, what that means for engineers is that Predibase is purpose-built to provide a best-in-class developer experience with simple abstractions and full control. One principle that we talk about a lot at Predibase is this idea of revealed complexity, where it's very simple to get started and get those initial results, but it's also easy to dive into more complex functionality, because we often see that machine learning is fundamentally a very iterative process. Also, we provide efficient fine-tuning. So as I mentioned, you can use any GPU from a T4, like a commodity GPU, all the way up to A100s, and doing all of this in a very fault-tolerant and reliable way. And then finally, we also offer cost-effective serving, so that you can use and make use of managed auto-scaling engines that scale up and down to meet demand, as well as this idea of dynamic adapter loading, where you can serve hundreds of fine-tuned LLMs at no additional cost to the base LLMs. And so with that, I'll hand it over to Connor, who will now walk through a demo to show you all of this live in action.
All right. Thank you, Abay. That was an awesome walkthrough of RAG versus fine-tuning and those specifics. I'm going to go ahead and share my screen here. And all right. Okay, so I'm going to walk through a demo flow that's going to show how we fine-tune models at Predabase, and doing this on a specific example, which I will describe in a second. So what we're looking at here right now is just the home page for the Predabase UI. We have a handful of walkthroughs and quick start guides to help you get started. But for today's demo, I'm actually going to go into a use case where we have generated a structured JSON that is basically automating some customer support capabilities that you may build out at any tech company or any company that has a customer support wing for that matter. So let's take a look at the data set and describe the task that we're going to be going through today. So I have this data set called consumer complaints. And if we take a look at the preview, what we're going to see is we have a handful of rows in here. So let's just dig into this. The first row I want to, or basically to describe the task, this data set is basically a data set of complaints that have been raised against a financial institution. Each row is an individual complaint, and each complaint has a handful of metadata corresponding to that complaint. So we have the product that the customer was complaining about. In this row 1, it's going to be credit reporting. We have the issue that they were complaining about. So the credit reporting product, the user was complaining about incorrect info on that report. And then we actually have the complaint itself, which is called the consumer complaint narrative. And so we have this long complaint that the user raised against the credit reporting product. You can see it's different for every single row. Some are longer and some are a bit shorter. Now, what we want to do is we want to take a model and fine tune it to be able to respond to these complaints. In addition to classifying both the product and the issue. And the value that this would provide would be intelligent routing. So if you can classify the product and issue that is like corresponding to the complaint that's being raised, you'll be able to route it straight to the customer support group that is responsible for responding to those types of complaints. Additionally, we want to generate a response that is customized to the customer's complaint so that we can alleviate any concerns and prevent escalation of this complaint before it happens. And this basically buys the customer support team time while they are coming up with a more like a better course of action to address the customer's complaint. And so something like that might look like this, where the LLM is generating a response where it is talking to the customer directly and addressing specifically the problems that the user was complaining about in the complaint narrative. Now, to top it all off, what we want to do is actually generate this in a JSON structure, which will allow us to basically put this LLM in the backend and automate the process. So it would look a little bit like this, where we have a product field where the product prediction has been generated. We have an issue field where the issue's been generated, and then we have the generated company response. And you again have that generated field. And the LLM producing all of this will allow you to automate this system in your backend and provide that like instant response to the customer in addition to that classification. Now, what I'm going to do now is show you just what a base model would do trying to generate this kind of thing. So if we go over here, let's go to the query window. And we're going to take a look at Llama 7 billion, just the base model, And we're going to take a look at basically how the model would do generating a response from just a query for a random complaint I picked out of the data set. So on this first row, what we're doing is we're basically telling the LLM that it's a support agent, giving it the context, telling it to generate a structured JSON output and contain the product, issue, and generated company response fields. It's basically telling it exactly what we want. This second row, we have a complaint where we have just inserted the complaint from the data set. They're complaining about some product Equifax being hacked, and they are worried about identity theft. And what we want is we want the LLM to generate a structured JSON output. So looking here at the response, you can see that it started to generate some JSON, but it didn't really classify the product because Equifax is like the company, and the issue, I guess that's pretty great. But if you actually look at the response, you can see it kind of just repeats itself, saying like, we're working hard, we're working hard, we're working hard. So if you were a customer and you received a kind of response like this, it probably wouldn't satisfy you. And if you actually read through it, it doesn't really make any intelligible sense. Now, let's jump ahead and let's take a look at the model that I fine-tuned, and let's see how it does. Don't worry, I'm going to get into how you do the fine-tuning process in a bit. But we're going to run this same query with the new fine-tuned model selected. And we'll give it about, generally takes a few seconds here. Awesome. So you can see now at this point, we actually have generated the full JSON structure. We've identified that the product is credit reporting, and the issue is a problem with the company's investigation to an existing problem. And you can see here that the actual response being generated is specifically addressing the customer's concern about the hacking incident, and then also addressing their concern about identity theft. Now, this is a lot better. And so as you can see, this is a reason why you would want to fine tune on this, this kind of use case with like structured JSON generation. But let's get into actually what the process of fine tuning a model would look like and what it takes. So for that, I'm actually going to jump into this Colab notebook that's going to show you what it takes to fine tune a model. So the first step is to authenticate into Predibase. Pretty simple. The next step that you're going to want to do is to grab the data set. So this grabs that same data set that I showed you earlier. What we're going to do is we're going to teach an LLM to fine tune the model on that data set that I showed you. I'll show you in a sec here what the fine-tuning prompt is. Now, this is very important, and this is going to look very similar to that prompt I was passing into the model here. And the reason we're doing that is we basically want to tell the model exactly what it's supposed to do, and then we're going to provide it with an example that shows it like what it should be doing. And that process of repeatedly looking at like what the model like we're asking it to do and what it should be doing is how it's going to learn over time to be very good at generating this JSON response. So I'm actually going to run this live here. I'm going to log in. And the next step, the only last step required to fine tune is basically just specifying the model you want to fine tune. So as I alluded to before, we're going to fine tune the Llama 2 7 billion model. And then you just call this LLM.fineTune method. And we're passing in that fine tuning prompt I showed you up here. Now, while this is going, it will give you a little log here that allows you to actually jump back to the UI and watch your model train in real time. Now, what this will allow you to do is basically watch your model progress through the process of fine-tuning. You can see each stage is detailed out for you here. You can actually look at the learning curves for this model in addition to any other metrics. So we can take a look at the loss or these blue metrics. There are a handful here that can help you evaluate the performance of your model. Now, jumping back into the notebook, once we have that model fine-tuned, we actually are able to deploy it and then start querying it. So we have this fine-tuned model here where we can actually get the model that we trained. And so this model that we trained is going to be like the same model that you trained over here. This is version 8. Looks like I'm doing version 2 in this demo. And then you just call fine-tuned model.deploy. You're going to give it a name for the deployment. So if you notice, this was the same name that I deployed right here. So the same model that we're using. If you have already deployed it, you can also just get the deployment that you want to use, and you can query it that way. But now I'm going to go through like a couple of more I guess examples of complaints and have the model generate it. So this one we actually already saw. This is that same Equifax complaint. But we can actually go ahead. Let's take this other one here, where someone's been receiving too many calls from an entity and they think they're being harassed. So now that we have this consumer complaint, we're going to pass it into the model. Basically, this is the same prompt that I passed into the query window as you saw before, and we're injecting that consumer complaint about the harassment right here. And we're just going to run this, and we're going to see what the model generates. So let's give it a few seconds here. All right, and as you can see, it generates a pretty good JSON structure here with the product of debt collection attempts to collect debt not owed. And we basically are addressing the customer's concern directly. Looks like we telling them that the team's going to review the information and get into it, and we're apologizing for any inconvenience caused and appreciating their patience. So this is basically an overall example of how you can basically automate the process of like intelligent customer support routing and automated responses. There's also ways to improve this. This is trained on a pretty small model. As you saw, I was using the Llama 2 7 billion model, but we can also do 13 billion parameter models and 70 Llama 2 70 billion parameter models as well. We are working on that. But all in all, this is just a great use case for fine tuning. And so with this, I'd like to close out and move on to the Q&A section.
Wonderful. Thank you, Connor, so much for walking us all through that. So again, we've had a really great demo, some good overview on fine tuning versus RAG, when to use which. And I really appreciate, I've just been following along with the kind of Q&A and discussion going on in the chat, and really appreciate all the engagement there. So we have a good list of questions coming up in the chat already. Let's see. I'm just looking at,
I think,
Connor, do you?
Yeah,
go ahead.
I have one that I think so. I didn't go into this specifically, but I can. Maybe I can share my screen again really quick here.
You bet.
Let me see. So the question specifically was, what were the hardware setup and GPUs that you used, which is a great question. So one thing I failed to talk about on this page. So if you remember back, once you kick off the fine tuning job and you have this link to the UI, one of the tabs, as you saw, was the learning curves tab, but an additional tab you have is this compute tab. And now this tab will show you exactly what resources you were using. So right here, you can see I'm using a G4DN 2X large, which is a single T4 GPU from NVIDIA. And this is a pretty cheap GPU to run. I think given the time it took, this took less than 2 hours in total. So this should have costed me under $5, I believe. That being said, you do have full control over the compute that you want to use. So if I were going to jump through, let me just show this really quick, training a new model. So let's say I wanted to fine tune a large language model. Maybe I want to use Llama 2 13 billion. And we jump over to this compute tab. You can see I'm using a G5 for the Llama 2 13 billion, but maybe I want to speed it up a little bit, throw some more speed and memory at it. I can actually increase the amount here as well, and this will automatically resize the engine for you. So I guess all that to say, you have full control over your compute and which engines that you are using to train these models.
Great. Thanks, Connor. We have a question in the chat. Oh, it's moving quickly. What model do you use for creating the embedding? Suppose you do not want to use OpenAI embedding due to security. Can you speak to that one?
Gotcha. Yeah. So this sounds for the embedding models, this is going to be for the RAG use case. So you essentially have like the LLM provider, and then you have the embedding model to embed the query, and then also like your data corpus. And so in that instance, when you're using an embedding model, as you mentioned, you can use OpenAI to embed those models, but as you also correctly mentioned, you'll be sending your data over the wire, and that may not be desirable. So one of the things you can do here is you can use any open source embedding models, like Hugging Face has a handful that you can use. We actually have a tutorial in Predabase that shows you how to like use Predabase to generate a RAG system. If you're interested in that, like please reach out and we can work with you. One thing to look forward to in Predabase is we are looking to support our own custom fine-tuned embedding models. So you can basically come in here, fine-tune or build your own embedding model that will like help take care of that step of the RAG process. And then you can serve both that and the LLM through Predabase to build your RAG system.
Thanks, Connor. Another one from the chat, is fine-tuning a good fit for classification tasks?
Sorry, you cut out there for a sec. Well, could you repeat the question?
Yeah.
Oh, yeah. Is fine-tuning a good fit for classification tasks?
I would say so, yeah. Anecdotally, I've trained a handful of models on classification tasks. It's still going to be a text-to-text generation. So you can imagine like a document and you're like doing document classification, or you have like some sort of like email or any body of text coming in you want to classify it to some sort. And the models actually do pretty well when fine-tuned on classification tasks. Predabase also supports other like less powerful models for classification tasks as well. We do have an entire like traditional machine learning, deep learning offering, which can allow you to basically train a model that will receive the same level of performance, but maybe won't cost as much as a full LLM. And that's an option too. And like the good part is experimenting with this in Predabase is all very easy and quick. So you can try out what works and then choose the best solution for yourself.
Wonderful. Another question about, Abe, you talked about a lot of different fine-tuning methods. The question is, which fine-tuning method do you feel works best? There are a lot right now, like QLoRa's, Llama adapter, prefix tuning. I imagine the answer is it depends, but I'll turn it over to you too.
Yeah, sure. I think, at the end of the day, I think a lot of this ends up being experimental. And I think that's where Predabase really shines, is that we allow you to start with like some defaults. So we have some out of the box like training templates where we give you things like LoRa, QLoRa, things that we've seen work very well. But we also allow you to kind of experiment with other maybe not as popular methods, right? And so ultimately, like there are a lot of knobs you can tweak, from the adapter you choose, the level of quantization, and so on. But I think ultimately it is a matter of just kind of like trying the best practices and then seeing if that gets you the good performance. And if it doesn't, being able to kind of explore other options in a pretty streamlined way.
Great. Here's an interesting question that I feel like we hear a lot. Where do you get the data sets for fine tuning? From open source sources? I know we've talked about a lot of kind of creative workflows for helping with that cold start problem for fine tuning.
Yeah, this is a great question. I love this question. So as like the most unsatisfying answer that always comes is like it really depends. But there's also a lot of tactics that you can, I guess, lean on to help you generate these data sets. So as I mentioned before, a good rule of thumb is around 1,000 rows. Again, it's very task dependent. You can sometimes work with less, sometimes requires more. It's a great place to start. Now, what we like to do to kind of generate these data sets is we like to use larger language models to actually bootstrap the data set that you are going to use to fine tune. So one thing you can do is you have a task in mind that you want a large language model to perform well, and you want to fine tune it on that. Now, what you can do with this is you can basically manually come up with like 50 to 100 rows yourself by kind of giving examples of like what you think the model, like an input should look like and what the model should be responding to that. And then you can use a model like a Llama 2 70 billion, which is pretty powerful. And you don't want to serve it 24/7, but what you can do is you can use that to basically say, generate me like 100, 500, or X number of examples of or duplicates of each of the like 100 manual examples you put together, and your 100 example data set will then kind of balloon into a like 1,000, 5,000, 10,000 example data set that you can then use to fine tune the model to do like very well on the specific task you want. I've actually worked with a handful of customers doing this, and it's a pretty successful process. So if you are interested in that, like please reach out and I can show you more about the process.
Thanks, Connor. Another one from the chat. Could you comment on the effect of weight or bias of internal fine-tuned data to pre-trained LLMs?
Yes.
That one was a little further up.
Yeah, I think I saw that earlier. Just want to read the question myself to no, I think I'm missing it. Could you just repeat the question one more time, Will?
Yeah. Could you comment on the effect of weight or bias of internal fine-tuned data to pre-trained LLM?
Sure. So I guess basically when we're talking about like bias in a model, it tends to like models when they have seen a bunch of data, they can bias off of the data that they've seen. So let's take just a contrived example of like your customer support, for instance. If you trained a model like I showed you on like the customer support realm, and it basically you've trained on tons of different inputs from customers, but the model like may learn that if it responds like it may learn to respond like well to some like customer like like customer complaints that have been like raised in some way and not another. And pretty much what all this is going to like drive or like I guess tie back to is the actual data that it's seeing. And so when it comes to like bias and in the model, really what you're going to want to do is focus on the quality of the data set that you're providing, because that ultimately is going to dictate the bias that the model is displaying at production inference time.
Thanks, Connor. All right, recent question. Can we perform LLM fine-tuning in our own environment instead of Predibase cloud servers?
Yes, absolutely.
Yeah, definitely. We offer both options. So if you prefer to have us manage the infrastructure on your behalf, definitely an option. We can also deploy it directly into your own VPC across any cloud. So whether you use AWS, GCP, or Azure, the data and compute are co-located within your environment.
Let's see.
I actually have one, Will, that got brought up. I think it was a question from Ramesh, which was, do you provide compute environment and tools for development and deployment? So that's a great question. And so there's a few things to unpack here. The first is, as Abe mentioned, we have these two offerings. We have like the SaaS platform, which runs all in the Predabase servers. And then we have a VPC offering, which allows you to run within your private cloud. We support Azure, AWS, and GCP. And basically, when you are using the VPC style of deployment, then we actually will do the model deploying for you. So whether you want to deploy an LLM and run inference on that, or if you want to deploy like a smaller model, we also have a ton of ways to like serve one LLM and then fine tune many models and then hot load those models on top of the base fine-tuned LLM. This allows you to kind of have like a many to one fine-tuned models to like serving costs, which is very helpful. So I guess like all in all, we totally abstract the compute for you, and we totally will make sure that that process is seamless. We take care of all the deployment and training for you. So all you really need to worry about is like what you want to do with like the large language model, and like at that point, and then like working with Predabase to like build that model, and then we take care of the rest for you.
Thanks, Connor. One of my favorite questions just popped in. Michael, thank you for answering it. But who owns the fine-tuned model? Is that the user's IP, or is that Predabase's IP? And unequivocally, the model, it's your data, it's all your IP. We're just the platform that helps enable it. There was a discussion earlier in the thread about kind of our business model and pricing and what that looks like. Abe, do you want to just speak to that so that folks not following along with the conversation can hear it?
Yeah, sure. So I think the pricing model varies slightly between our SaaS offering, where we have our managed infrastructure, and our VPC, where it's deployed directly into your environment. I will note that currently we do have a combination of like a platform fee plus consumption pricing, but actually very soon we are launching like a fully consumption-based pricing tier, and that will actually be one of the most competitive ways to serve fine-tuned model in the market. And so if that's something that's very interesting to you, I would definitely recommend reaching out to us at support@predabase.com, or stay tuned for in the next week or so, and we can point you to that page as well.
Thanks. Connor, do you want to take that last set of few questions that just popped up in the chat?
Oh, yes. So it looks like from Tekken, sorry if I'm butchering your name. It's have you ever faced hallucination problems, or have you ever needed to retrain from scratch, or have you ever are you only training the last layers of any LLM? So the first part, which is have you ever faced hallucination problems? And the answer is absolutely. Models, especially the base models and the smaller models, when you tend to ask them questions that they don't know the answer to, they tend to either hallucinate or repeat themselves or generate something that is largely unuseful for the end user. Now, this is where fine-tuning is actually like a great solution for this, because if you have a task where you want the model to generate some code, or if you want the model to respond to like questions in like a chatbot interface, or if you want to do like customer support routing, whatever, what have you, when you fine-tune the model, you kind of teach it how to answer those questions in a way that it won't rely on or it won't run into this wall where it hallucinates anymore. And you can kind of see that when you evaluate the model. You throw like one question at the base model, and then you throw the same question at a fine-tuned model, and it like can answer it. And then you keep repeating this over. We have a way to run batch inference as well to evaluate this too. So yes, we do run into hallucinations, but fine-tuning is a great solution for that. And then have you ever needed to train a model from scratch? So right now we focus on, as it's kind of a buzzword in the industry or the market, but it's LoRa. So we do parameter efficient fine tuning with LoRa, which allows us to do this we call it dynamic adapter loading, or that hot loading of the models. So you only have to serve one large language model, but then you can basically run inference from many different fine-tuned models. And that is made available through this parameter efficient fine tuning, where we're only fine tuning like a section of the model. We are also working on full fine tuning as well. Let's say if you have a use case where, like maybe in medicine or something, you need the large language model to be very good at like talking about medical jargon, or answering like things with clinical notes or things of that nature. That might be an instance where you want to fully fine tune a model, and we should be releasing that like relatively soon. I don't want to make any promises, but it's something that like Predabase will or already can do.
Great. We had another good one, I think, from Don, Connor, and Abe. What tools does Predabase make available for evaluation? Much of the work of productizing LLM-based systems is experimentation, testing different models, embedding generators, fine-tuning approaches, and their combinations. And academic benchmarks are not good indicators for commercial products.
Right. Yeah. So when it comes to evaluating your large language models, we kind of have two things available for you. We have the whole set of metrics that we showed in the model version view, but as you said, like sometimes those benchmarks tend to, or those metrics can be a little bit confusing, especially for like the end users who don't know what they mean. So the way that like makes it really easy to evaluate your models in Predabase is doing this like manually and then at scale with our like individual inference and then batch inference. So what you can do in the SDK or like in the UI. So the UI, you can basically just take a model that you want to like test out and evaluate. You can ask it questions over and over, try it out, see how it's doing. But a more foolproof way of determining if your model is ready to go is what you can do is you can provide it like a whole table of rows to evaluate on. So if you trained a model to, let's say, route customer support, like this example that we were going on in the webinar, or in the demo, what you can do is provide like a data set of like 100, 200, 300 rows that you want to evaluate and have the model make a prediction or generate a response for every single row. And then you can go through and like you can check to see how your model is doing, and to give you that confidence that you want to put it into production.
Great. How about this one from Neville? How long does fine-tuning a 7 billion parameter model typically take?
Yeah, great question. So it depends. It depends a lot on how big the model you're training is, how much compute that you have available. So for the Predabase free trial, we restrict all of the fine-tuning jobs to a single G4 DN2X large, or which is a T4 engine from NVIDIA. And then it also depends on your data set that you provide. So the kind of levers that you can turn here are basically the data set. The more data that you have that you provide for the fine tuning, the longer it's going to take. That also impacts the quality as well. So it's kind of a trade-off, which is why I say like I like to start at 1,000 rows and then like move from there. Additionally, with those engines with paid Predabase customers, you have the ability to like throw more compute at the job. Additionally, like you can maybe hook up like a G5 instance or like an A10G from NVIDIA, or even A100s, which can kind of get through these fine-tuning jobs a lot quicker. So all that to say, it's very variable, but I would say like generally speaking, when you're starting off, it can take anywhere from like a couple hours, 2 hours to like 10. I've seen models run like even over 24 hours, but usually we restrict those 24-hour plus runs to models where you're like not experimenting. You kind of have made a POC, you know what it's working, and you just want to like kind of squeeze out that last bit of quality.
Great, thanks for that. How about how do you pick the number of epochs and other parameters for fine-tuning to avoid overfitting? How does Predabase allow you to monitor that?
Great question again. So Predabase, I know I showed you how quickly it is you're able to fine tune a model with just like those 4 function calls. we actually provide a ton of control for you. And maybe this would be a great time for me to share my screen um, and show you just like what the configuration looks like. But essentially what we have here is, you may have seen me go past this cell here, but here's an example of like a partial configuration that we would use to train a model. These configs can get very big, and we try to make it easy for you by choosing the most optimal parameters for your first few experimental runs. That being said, on further runs where you might want to address things like overfitting, or you might want to address other concerns with like your model quality, you have the ability to change these parameters to whatever like you want. So let's say, for instance, quantization. We always like use a method of 4-bit quantization for our models starting out the gate. However, it may have adverse effects on quantity at the expense of, or like with the trade-off of giving us like more memory. So you can actually increase this to 8 with 8-bit quantization, and even like floating point 16, which can give you even more precision and higher quality. There are other types of parameters under like the trainer. I won't go into every single one, but all that to say, when you're working with these models, you have a ton of control when building these models, and you can get these pretty complicated configs that are going to like get you that best model that you want to work with. Cool.
Great. We have another one about which one is improving the accuracy of LLM results, fine-tuning or retraining?
Right. So which one is the accuracy? So I guess when it comes to this, like fine-tuning is definitely going to like help increase the accuracy. It depends again on the task. Like if you ask a large language model, if your task is just to like name me the capital of like a random country, like fine-tuning a model like probably won't get you like any more accuracy there, because the large language models like, probably already know what the capital of like every country is, right? But if you have like a more complicated task, fine-tuning would work there. Retraining, I'm guessing this means like fine-tuning or fine-tuning the whole entire model, as opposed to just like fine-tuning a small section. And that basically will modify not some of the weights where we do in parameter efficient fine-tuning, but it will actually modify all the weights. And that can be, I guess, both of these instances will improve the accuracy. Like if you have one of the more complicated tasks, I think the question is really, do you want to dedicate the resources to full fine-tuning, which can be very, very expensive, whereas like parameter efficient fine-tuning can be, it actually tends to be like way cheaper and faster.
Totally makes sense. We are just about to come up against the top of the hour, so I'll try to get through one or two more quickly. Could you maybe talk about when you might want to use a Llama 2 model versus a GPT for all or other model?
Right. So we at Predabase, we are kind of pushing the Llama models. We are actively adding Mistral as well, since that has like now been hitting the tops of the leaderboards. And the reason that we use these models and none of like the GPT 3, 3.5, or 4 models is because the Llama models and the Mistral models, they're all open source. And at Predabase, we can basically take any of these Hugging Face models and we can fine tune them and serve them for you. And then that is how we can actually like allow them to be like your intellectual property, because they're open source. With any of these like GPT-4, for instance, like we can't use that because OpenAI owns that model. And so that is actually a closed source model, and we are not able to fine tune that for you. While it is an awesome model and it produces like excellent results, I use it frequently to like generate like synthetic data sets. It's the type of thing where it also might be like way too expensive for you, whereas these like smaller Llama models can do just as well on a particular task, but they cost like a mere fraction of the cost.
Great. And that's perfect timing. We are at the top of the hour now. Thank you to the two of you for walking us through this and for that hefty Q&A. Appreciate that. Happy to keep you guys on your toes. And thank you everyone for dialing in today. We're excited to stay in touch and see you on our next webinar. Thanks for all the discussion and for answering those polls. And yeah, just reach out to us if you want to try Predabase on our free trial, or if you have any questions related to what we talked about today. So thanks everyone so much. Take care.